will join me and flip to page, whatever the start of chapter 3 is, we start adding some new pieces. So we start adding the idea of being able to do branches. We wanted to be able to do some loops. And we want to be able to figure out how to make our programs do some more interesting things. So I know everybody forgot everything we did. So we're taking in things like an if statement. We're going to be able to create a way to loop things. We're going to look at random numbers. So we're going to be able to create some of our first games. And one of the reasons I chose this ancient old cheap text was it really revolves around the idea of creating games and creating kind of these really quick little scenarios. So if I look on page, whatever it is, page 49, where we begin this subject, we talk about doing random numbers. We talk about if statements, else statements, while loops, and they use that term pseudocode again that you guys are already familiar with. And that pseudocode is a really great way we can create fake code that we can then send off to programmers if we're sending it off, or other people depending on what we're going to do. So the first thing we're going to do is we need to figure out something kind of neat. We want to figure out how to create random numbers. And we use random numbers for a lot of things. So if any of you have been to the casino, they use those random numbers. Bless you, by the way, over there. They do use random numbers to generate all those spins and things on your gambling devices. So we're going to learn to do something similar. So just a real quick backup. I launched idle over here. And in idle, I'm going to use the script mode. That interactive is kind of handy for some things, but a lot of times we want to use that script mode. And just a quick overview again, remember that pound sign gives us our comments, and we always want to put our name at the top of everything, just so when I download them I can go, yeah, I know whose that is. Makes it handy to do it. It's really handy if we say, okay, well, I also need to know what the name of the program and some other information about it is. So in this case, we're going to call this Craps Roller. And we're going to simulate rolling some dice. So kind of a handy first step. We can learn to do some things. So the very first thing we need to do, and at the bottom of page 51, they discuss this idea. And it's that we don't have a random number function built in yet. So one of the things we have to do in a lot of cases is we have to import in modules or libraries of functions. And so it's pretty tough. Import. And notice it's a keyword and it changes the color. And I'm going to import a function library called random. And when I do that, now I have the ability, and it gives us a few other things, but there's a library called random. And so when we run it, it actually pulls that into our code and says, okay, now you have all those functions available. And you're going to see as we go along, there's a lot of other ones. But we're going to try the first time, we want to import random. Well, we know we need a couple of dice. And so I'm going to call it dice 1, if I can spell there, dice 1. And I'm going to set it equal to 0 for now. So in other words, I've just created that variable, dice 2 equals 0. So at the beginning of my program, just at a good form, I said I created dice 1 and dice 2. Well, I'm going to set dice 1, and I'm going to set that equal to, and here's where we use that dotted notation again. Because I imported that library random, so now I'm going to access that library, random, dot, and I'm going to use one called rand integer. And so rand integer will only give me integers, and I'm going to put in the values I want. So I'm going to put in a value between 1 and 6. And so now I have that dice equal to some kind of random number. And so now I could go to the end of my program, and one of the things we almost always do is we have that input, and in this case, I'm going to put this in here and say press the enter key to exit. And so we put in our input that just holds the program open for us. And I want to display the result of that. So I'm going to print, you rolled a, and then I'm going to put dice 1. And for now, I'm going to end that. And so I'm going to run this program. So I'm going to have to save it. So File, Save. And I want to make sure I pick wherever it is I put it. So in this case, I'm going to have documents, and I put a Python folder. And I'm going to call this Craps Roller. And so now I have this program, and I can run it. Oh no. So we end up with some kind of an error. So I need to go back up, and I need to look at my code and see if I did something odd, which it's very possible I did on my blurry screen of doom up here. So dice 1, so it's telling me that we have an error in line 8. And so if I go up here and I go 1, 2, 3, 4, 5, 6, 7, 8, it's telling me that I have some kind of an error in there. And when I look at that, I go, oh yeah, I don't need a hyphen, I need a comma. So now I'm going to try it again. And it says I rolled a 5. Okay. Well, I'm going to try it again to see if it's going to actually give me a different number. And so, great, I can make a random number within a range pretty easily. So an integer from 1 to 6. Some of you may play games like Dungeons and Dragons. Does anybody in here play Dungeons and Dragons? No? You guys are not that nerdy? Well, in Dungeons and Dragons and a lot of other games like that, there's dice that are much larger than 6, and you can buy like a 12-sided dice. And so we could actually create this with a 12-sided dice. And now it rolled a 9, and so we could do the same type of thing. Well, I'm going to expand on this program because one of the fun things is, so 1 to 6, is there's multiple ways we can do it. And so one of the other ways we could do it, so dice 2 equals random, so same type of structure. I'm using that dotted notation. I'm going to use the rand range. But rand range works a little differently. And so rand range says I want 6 different values. But the problem is the computer always starts counting at 0. And so it would count 0, 1, 2, 3, 4, 5, 6. Or is it going to get to 6? So it does 6 numbers. So 0, 1, 2, 3, 4, 5. So the way we fix that is we just add a 1 to it. And so now I'm going to go back up and I'm going to change this a little bit. And I'm going to add to my print statement. And I'm going to put both dice in there. Dice 2. And so we could actually then say, here we have both dice. We can see what they do. I'm going to run this and I want to make sure it works. Nope, I have something weird in my print statement there. Not sure what I typed. You rolled a... Is that a period instead of a comma? There we go. Chunk. All right, so I rolled a 4 and a 2. Well, I'm going to run it again. Let's see what I get in this hand. A 1 and a 4. And so now we have the ability to roll dice. We've created a way to create the beginnings of a craps program. If you go up to the casinos, it's a really popular game. Somebody told me that they played it once or twice. So, a couple of key takeaways here. We know that there's multiple ways. So on page 52, we know that we have to import that random library. If I don't, so then I can try this. And I always encourage you to try these things. So if I take out import random and I run this, it's going to say, well, what is this random function you're talking about? I don't know what it is. So now I can go back in and go, okay, well, I'll put it back in. Now I run my program and it magically works. So we're importing that library. And so 52 talks about how we can do the rand integer function. And a lot of times that one's really, really handy. And then it tells us about the rand range function. So generally we wouldn't do two different types. For a lot of our cases, I really like this rand integer because it gives us that by default. It's very explicit and says, hey, we're going to roll a number from 1 to 6. Or we could do it from 2 to 5 or 13 to 17. Whatever numbers we need, it gives us very explicitly. So it's a great way for us to do that. So one of the things that'd be really handy then is if I could put in a statement that said, you know what? If you rolled a total of over 10, you win a prize. Maybe we could put a statement in there. So the next piece this chapter has that I think is really interesting is we want to work on an if statement. And so we're going to create a really quick password program. We're going to create a program that will ask for a password and see if it is the password that we have chosen. Now, those of you that are in my cybersecurity class or have been in there, you're going to know that I'm going to throw up all kinds of red flags that this is really not how we do it. But for a quick demonstration, this is kind of a fun thing. So I'm going to go up here and I'm going to eliminate all of these pieces for now. I'm going to leave my name. But I'm going to put in password now so I know what I'm doing. And I'm going to leave that input on the bottom. And I'm going to do a file, save as. And I'm going to call this password. And so we're going to create a program that's going to look at different types of passwords. So the first thing we're going to have to do is put in a print statement up here. This program will ask for your password. And so we can put in all kinds of other print statements. So in the book they talk about welcome to security, blah, blah, blah. I'm not going to put in all those because I'm feeling a little lazy. But I am going to do an input statement. And so I'm going to create a variable called password equals input. Now we don't need to do the int, we don't need the integer function because what we really want is a text value. Please enter your password to gain access to the nuclear codes. So we created an input statement. We've done that before. That's nothing new. Well, now we want to be able to see if we can compare it. And so we're going to type if. And notice if highlights, so it tells us, oh, yep, it really is some kind of a function. And so if password. And so notice it started highlighting because there's a key. And we're going to make a comparison. So if it's equal to and we're just going to hard code in a value. In this case, maybe we'll use secret. If password equals secret. Now, here's where the hardest part of this is. Over on your right-hand side of your keyboard, there is a semicolon. And I have to use the semicolon. And if I don't, this program blows up and it doesn't work. And that's the hardest thing to remember, is to hit that semicolon. And when I hit that semicolon, it tells the program that, yep, I'm going to come in and I want to do something different. So when I come in, I'm going to do that, and I'm going to say, well, all right, let's do a print statement, and it's going to say access granted to your secret file. Now, I'm going to look at this really carefully, and I'm going to say, well, all right, is that right or not? How do we deal with it? So up here I have my colon, and if I use the colon, when I hit enter, it automatically indents this. So everything in this indented area is going to happen. So if I do another print, it will also do that. Please do not blow up any countries today. So all of that's a block. And remember, I talked a lot about the indenting is going to be an issue. So in here, all of this is indented, and that says that's all one block of code. And so this is obviously kind of silly, because we're saying, is your password equal to something we hard-coded? But for now, we'll actually take a look at it. And so we're going to save it. So I'm going to hit F5 to run it. And apparently I have something kind of odd. Oh, yep, sorry. Thought I did. So, if it'll let me edit. So, one of the keys and the weird things in here is we have an equal sign is an assignment operator. And it says, this is what I'm assigning. So when I assign it up here, that says the value of this input is assigned into password. When I do comparison operators, we have to explicitly say, we're really saying, is this an equals? And so one of the odd things is that we end up with that double equal sign in there. So now let's try it and see what happens. So now it says, please enter your password. And I'm going to put in something wrong. And it just it dumps me to the exit sign. Okay. So let's try it again. And I'm going to type in secret. And now notice it actually plays and says access granted. Please do not blow up any countries. So that seems to work. We can have an if statement that works. So we could combine those, and we could have done an if statement, perhaps looking at the roll of those dice. So this gives us our if statement. We can make these run, and we could do all different kinds of things with them. We don't have to just do a print statement with it. So on the top of page 56 is our list of some of the operators that we could do. So we don't have to just do an equals. We can do a not equal to, which is an interesting one to do. And in some of the languages, not equals, so here, we could change that. In a lot of programming languages, not equal is this, greater than or less than symbols combined. In Python, it's the exclamation mark equals. So we have greater than, less than, greater than, or equal to. And so sometimes those come into play. And we do have to worry about how we do our comparisons when we start looking at this. So if I'm comparing password, and I want to say password is equal to secret, that works. I'm comparing a variable to a variable, and they're the same character type. They're both strings. But if I tried to compare it to, let's compare it to the value secret. So now I'm going to set up another variable up here. So I'm going to say secret equals 1, 2, 3, 4. A number. Now if I run this, it's going to get to the part where it's going to let me put in a code. And I'm going to type in secret. And, oh, it's going to say, no, that's not the same. And so in a lot of cases, it'll blow up because we're trying to compare an input, which is a character string, versus a number. So in this case, it just kind of ignored it and said, no, they're not equal. But I could also do it this way. And now I'm comparing a string with a string. And so we have to be a little careful of doing that. So depending on how it works, sometimes it'll ignore it and go, yeah, they're not equal. Sometimes it's going to go, I can't compare them because they're two different data types. I'm comparing a name with a number, and that doesn't always work. So the bottom of page 56 talks about those indentions. And those indentions are critical. So if I don't use those indentions, if I back this up, it doesn't know that that's part of something that should happen then. It just says, oh, yep, I'm going to run this code, and oh, that's more statements in the code, because it doesn't see that there's anything in there. So the easiest way I've found is use the tab button to put it out there. That tends to be the same space. We sometimes have to worry a little bit about spacing if you have an extra character in there. And so in some cases, a single character can break that block. So make sure that they're lined up. If you can use the default spacing. So here I'm going to hit enter at the end of that colon chunk. And so now if I could put in another print statement, or I could do something else. Hello, Dr. No. So those indents become really, really, really important. So we want to do this, and we want to make this program a little more exciting, a little more involved. And so one of the other functions we can add then is we can add the else clause. And so we have to think about our logic a little bit, but not only do we want to input our password, and we want to get an action that says, yep, your access is granted, we also may want to add something about a condition that happens if that condition is not true. So if this is true, we do these actions. Otherwise, we're going to do another set of actions. So we make a decision. So if the crowd at the club looks exciting, we're going to go to the club. If it doesn't, we're going to go to the next one down the street. Those kinds of decisions. So the key phrase we're looking for is else. And again, if I put that colon in and I hit enter, it jumps me down at the appropriate text block. And so I'm going to put a print statement in. Warning, warning, warning. You are an agent of the North Koreans. That's who we seem to be having an issue with lately. And so now we actually are going to run similar program, and we're going to run this. So 5 run, and I'm going to ask for my password. And I'm going to put in something wrong and see if it works. Warning, 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 you're an agent of the North Koreans. Well, I'm going to run it again and see if the other side works. So Z chunk. Close dialog box. So enter a password. I'm going to enter secret. And now it says, all right, you get this file. So we could change this same program really, really quickly. And we could combine those two of those. So I'm going to go back in here and I'm going to import random. And I'm going to delete some of this really quickly. And I'm going to set die1 equal to random dot. Which one do we want to do? Doesn't really make any difference. So we could do the rand integer. And so our dice game is only going to roll one game. So we could say if die1 greater than 4, print you are a winner. Then we're going to backspace and do an else. Print you lose. And so here we're going to run a game where we pull a die in, so we get a number for that, and then it's going to simply say you're a winner or you're a loser. We don't know what that die is, so one of the fun things we might want to do then is just print die1. Now we can run this. I'm a winner. And I know that it's a winner because it's a 6. And I just put that in as a test variable. But so now that I know that I think it works, I can come in and take that print statement and I can put my pound sign in front of it. And now I can make that line not run, which is a handy tip. So I put that statement in so I could verify my program worked. Now I've created this where it says, all right, let's check. And we can put in that several different statements. So maybe we go ahead and we do something here where we say, all right, I'm going to copy this statement and I'm going to put in a second one. I'm going to go in here and change that to die2. And so we might need that second dice here if we're going to create a program. So I've got it in there. So the other thing we might want to do then is we might need a statement where we actually have 3 conditions or 4. So let's think about rolling craps. When I first roll craps and I roll dice, are there different winning conditions at first roll? How do I win the first roll? You guys have been in a casino, some of you. I know. You've rolled dice. How do I win at craps? If I roll a 7, do I win on the first roll? It's the only time I want to roll that 7. If I roll an 11, I win, right? So I'm going to change this just a little bit. And I'm going to change this. I'm going to create one called total equals die1 plus die2. And so I'm going to change this. And I'm going to change that from die1, I'm going to change it to total. So total now, if it is not greater than a number, but if it's equal to 2, then I'm going to post you rolled snake eyes too bad. But I need another condition in here because that's not the only condition that could happen. So it could be 2s or anything else. So maybe I want to figure out if they've rolled a 7 or not. So I have another phrase in here, so LF. And notice, so it's really kind of else if, we've combined it together. And I'm going to put in there, so it's just like the if close. We can put in a specific condition. So if you look at that on the bottom of page 60 and 61, they do a mood program using LFs. Well, I'm going to do it using the dice game simply because I don't want to create this ASCII art. So I'm going to put in an LF total equals, so we know that certain values. So if a 7 comes up, we win, right? So I'm going to do an LF for a 7. 7 colon chunk. And then I'm going to print you rolled a 7. You are an amazing dice roller. All right, so we know that there's another condition. So we could put in another LF. If total equals 11, so print you rolled an 11, you must be from Newark. Some nonsensical thing. So now we can check if they rolled an 11. So, and we could go in and put in ones for every set of dice if we wanted to. So in this particular case, I have a couple of conditions that win. So I have a 7 that wins, I have an 11 that wins, and I have a snake eyes that says you lose or whatever I had in there. We could also put in one for 12s. So I know that if the total is equal to 12, that you rolled a 6 on both dice. So I'm going to put another LF equals 12 colon it doesn't win you anything but my admiration. So we could go in and put in several different things. I'm going to save this and make sure it runs. See how many typing errors I have. Oh, I forgot a colon there. Good job. Way to go. All right, try it again. You lose. So in other words, I got some value outside of one of those. Well, let's try it again. You lose. Huh, I'm seeing a trend here. You lose. You lose. You lose. So, you rolled a 7. You're an amazing dice roller. So, I can double check this one again, because maybe I need to double check. I want to make sure that my total actually works. So at the beginning of it, I'm going to go ahead and leave that print statement in. And in fact, I'm going to print out die 2. And I'm going to print out total. And the reason I'm doing all those, I want to just double check. And I can use that as a tool to do that. So I'm going to go 5. Using old notation. All right, so there it says, so I rolled a 3 and a 1, or whatever it is, 5 and a 1 maybe. And it says, oh, you lose. So we could go in, and you could put in LF statements for all 12 of those if you wanted to. You could put in ones, because right now all the ones we've done are on the total. It doesn't have to be on the same variable. We can actually put it on a different variable. So I could say LF die1 is equal to, let's say, the value 3. And I could put an output in there and run a block of code. Now, it'll never run for me and work, but let's see if we can get a 3. You rolled an 11. So this is a way we can do a lot of simulation, and we can look at it. So the book has one. And the book has one called Mood Computer, which if I look at that one, so maybe you remember from many years ago something called a mood ring. And so this is the source for one that does a mood type of simulation. So it says mood equals random from 1 to 3. So there's 3 different possibilities. And it says, so if mood equals 1, you're happy. If mood equals 2, you're neutral. If mood equals 3, you're unhappy. And so in this case, this program, if I run it, just simulates and then puts in an ASCII art face that says, you are unhappy today. So this is just another piece of code doing the same thing. We're looking at those elifs and those if statements. So we've made a lot of progress here. We can do a lot of fun things with it now. And we can actually look at, on page 62, how they did those elifs. So one of the kind of interesting things we do, close that one out. I'm going to leave mine up here, is this else statement we can use kind of as a trap. So anything that doesn't fit the rest of our requirements, we can send it to that else statement. So it has to match specifically one of these other ones, or else it gets printed here in the end one. So page 63 has a table that shows the different conditions. So we can look at those. So those tables are kind of a handy thing to kind of highlight and take a look at what we're going to do there. So we put this together and we said, all right, now you have a certain set of dice. You're going to get some numbers. So I want to create a program that's going to act like a 3-year-old. So I'm going to set this one aside for a minute. I'm going to go File, New. And I'm going to bring open another window here. But I'm not going to close that one yet because I'm going to have some handy functions here. So I don't want to retype that input. So I'm just going to copy it over here. The less things I have to type, the better. And so I'm going to start at the top of my program. And I'm going to say, all right, well, I'm going to simulate what a 3-year-old acts like.